of inequalities, it's basically graphing. We're going to graph inequalities in 2 dimensions. Basically, you're going to graph, y is less than or equal to 2x plus 3. All the rules for graphing lines still hold true. You still go to your slope, you y-intercept, and you walk your slopes. But I'm going to show you guys what's called a quick graph today. It's when you graph stuff that's in what's called standard form. You may or may not have used standard form back in the day. Standard form was that ax plus by equals c. Vaguely remember that? If you think about the problems that we just had yesterday from the homework even, all of those problems are usually written out in that standard form. Negative 4x minus 6y is 11. Well, what's nice about standard form, really the only thing that's nice about standard form, is that it allows you to do what's called a quick graph. Let me show you what that means before we get into the actual stuff. Let's say we have the equation 2x minus 3y is 6. Does everybody agree that's a standard form of an equation?
Yeah.
Sure. It's got there were certain rules you had to have. A and B couldn't both be 0. They had a GCF of 1, things like that. But 9 times out of 10, they give it to you in the problem itself. It's already set, ready to go, aside from the ones that they hide in GCF and whatnot. When we go to graph something like this, what's nice is that you guys would probably say, okay, I'm going to get y by itself. I'm going to subtract 2x. I'm going to divide it by negative 3, and I have to watch all of my signs go through to get my y-intercept and walk my slope. Well, what I want you to start to think about is, what does it mean to be an intercept? An x-intercept, a y-intercept. For example, just by looking at this graph, if I am driving along, minding my own business, and I cross the x-axis, the y-axis there, what is my value for x?
0.
0. Good. So when I'm on the y-axis, my value of x is 0. Same thing holds when I cross down here and I cross the x-axis. What's my value for y?
0.
0. So what you're able to do is what's called a quick graph by cover and solve. If I cover up this, that means it's 2 times 0. What's 2 times 0?
0.
0. So I get negative 3y is 6. What's my y-intercept? Negative 2. If I cover this up, I get 2x is 6. That means it's 3 times 0 to find my x-intercept. What's x? 3. There's my x-intercept. How many points do you need to have to determine a line?
2.
In your graph.
I like this.
It's a quick graph. It's just cover and solve. What's that?
One more, please.
Oh yeah, absolutely, absolutely. This is basically how I do a lot of these graphs. If they're not in slope-intercept form, they're probably written in standard. I just cover and solve. I'm just finding my intercepts. Same idea. If I have 4x minus 5y is 10. Well, we'll just do plus. Whatever. If I cover and solve, 4x plus 5y is 10. It's at standard form. If I cover up the x value, it's going to give me my y-intercept. 2. Everybody okay with that?
Yep.
Okay. So my y-intercept is at 2. If I cover up the y value, it's going to give me my x-intercept. My x-intercept is at 10 over 4, which is 5 over 2, which is, in other words, is 2.5. Done.
Yeah.
Wait, but how do you know?
Clear the board.
Alright, so
So I look
4x.
at 5 y instead.
Alright,
What is y?
2.
Boom.
Alright, so get rid of 5y.
You're in 5 y.
Nice. 2.5.
Yeah.
Nice. I get it now. Nice.
I don't have it.
Any?
I don't think I do.
Oh,
Let me
she
check.
does. I know. It's actually around the
2?
I don't expect to be friends with her. What do you do? Yeah, friends.
Just those little got
Wait, so how do you know that they're on the zero? Like, how do you know which one?
I don't have any.
So I choose zero, so you just
Thank
make
you.
it because
I don't have any.
anything times by zero is zero.
I should
Wait, I was confused because you covered up the 4x, so it'd be 5 times 2.
Does that make sense,
It
guys?
would be
Yes.
Yes, sir. Hold on.
Does that not determine the slope?
It does determine the slope, yes.
No, because
Y is
like,
equal to 2.
the
And then that's
points,
why it's on
like,
2.
when it's right next to
Yeah, that
the
makes
form, you can't
And it's
tell
on the
the
y,
slope.
it's on the
Yes, you
y
can.
axis, because like it's always 0.
Opposite of B over A.
Because because you set 4x times 4.
McCann had a great question.
X is 0.
McCann had a great question here about slope, determining slope. If you look at both of these equations, on the first one we did, if you see your slope was up 2 over 3. Wait, so it's, I'm sorry, it's A over the opposite of B. I said it backwards. So it's, this case, your slope would have been 2/3. Here, A over the opposite of B is -4 over 5. So if I went through here, down 1, 2, 3, 4 over 5, this would have been here, but this is just the midpoint of it as it got to the 0. Okay. It's not something you really need to worry about, but if it's something you want to look at, that's fine. Okay. So it's A over the opposite of B will give you your slope, and it's the same as well. Like I said, it's not something you need to really, really worry. It's something. So if I go back to this whole system idea, oops, we need to remember here, what does it mean and how do you graph systems of inequalities in regards to less than or equal to, greater than or equal to, less than, or greater than? There was one change. Yes, sir.
For those, would you graph the same as you just did, except with the open close dots?
Yes, but instead of being open and closed dots, what we're looking at is we're drawing the line. It's either going to be a solid or a dotted line. Okay. So in this case here, are those going to be solid or dotted lines?
Got it.
Solid.
How do you know?
Yeah.
Wait, how do you know that?
We said the dot.
Well, remember the old rules here, guys. If you had less than or greater than, it was an open dot.
Yeah.
If it was less than or equal to or greater than or equal to, it was a filled in dot.
I remember that, yeah.
So we did it like that. It's the same idea. This means it's going to be a solid
Not an area.
line. This is going to be a dotted line. Okay? It's very easy to do. So we do this same idea on a graph. I should probably get you a little bit of graph paper. Have some.
I want more.
Everybody?
Here, grab a couple of sheets and you can stand around. I don't know if you guys need any. That's why I have more than enough. Pass and forth. I can teach you. All right, anyway. So I go back to the idea of this cover and solve and find some intercepts. Where's my y-intercept? Solve for y?
Yeah. Got it.
You gotta solve it. And then the other one's at 2/3. So it's, I guess I should have picked a better example to start with. Whatever. Now, when I connect those, they're gonna be solid or dotted between them.
Solid.
Solid.
Got it.
I miss everything, so it's okay.
Oh, hold on, Mike. Okay. The other thing that happens now with inequalities is that it splits the graph into two parts, a true side and a false side. What I mean by that is you have to go back and think about when you guys did inequalities with one single variable. For example, if you had a problem where it was x minus 4 is less than 3, what would you do to solve that and then graph that? Well, You'd add 4 and your solution was x is less than 7. Now, when you would graph that via a number line, you would start it out, you put 7 in the middle, some number to the left of it, and some number to the right of it. Vaguely familiar? At this point, then you would circle on the 7. Would you fill it in?
No.
No. Now, what side would this have to point to give it a true statement? Pointing towards 0 or pointing towards 10? 0. Because 0 is true, so I want to cover up the truth. Okay? Right. The only thing that's different now in regards to the double variable, your linear equations, is that instead of picking a single value to test at, you're testing it at what's called an actual test point. Test points are very easy to use. The one that I like to use all the time is 0, 0. Because if you look at it, does my graph go through the origin? No. So what I'm doing here is I'm going to check, does I'm going to use 0, 0 as my test point. Is this true or false? 3 times 0 minus 0, is it smaller than 2? Yes. So that means it's true, just like we would do before. We would shade towards truth. I would shade on this side of the graph.
Oh, I think I remember that.
Remember that?
Yeah, can you give me one
Okay.
minute?
Now, I hear a lot of you guys going with your pencils. Do it like that. Just draw a couple quick lines going up over there, because eventually you're going to have overlaps, and it's going to be cleaner to see with just some lines like that, okay? Now I do the exact same thing with the other graph. On the other graph, I have a y-intercept of 2, positive 2, very good. And an x-intercept of 1.
Yeah.
Guys, do cover and solve. Is it going to be a solid or a dotted line between those two?
Solid.
Solid. One thing that comes up pretty regularly with this, let's say you go through it and you're doing it in pen, which is fine, I don't mind if you're confident in your skills. And let's say you go through and you can't go back and erase the dots on a dotted line because you used pen. Is it okay if you just mark it and say, oops, this should be dotted?
I think so.
And if you point to it, if you make that error, I'm perfectly fine with that. If you automatically just drew the line and said, oh, I totally forgot to make it a dotted line, just tell me it was dotted, and that's okay. Is that fair?
Yeah.
It's common, it happens. I even screw up sometimes, go figure. It'll work. All right? Same deal. Did that line go through the origin?
No.
No, so I'm going to use it as a test point again. Is 2 times 0 plus 2 smaller than 2?
Yes.
Yes. So I shade towards the origin again.
Wait, so I got a question now. What if it does, like, touch the origin of that?
Then I'm going to pick this great question. Abby just asked, what happens if your graph goes through the origin? You just pick any point that's not on the line. Like 2, 6.
Okay.
It really doesn't matter. It can be on either side of the line. I just like to always use the origin if I can, because I can do math with 0 pretty easily.
Yeah.
I hope. Okay? Does that make sense what we're doing here? Your shaded region now, where those double things are laced over, means that any ordered pair in that set would be a valid answer for both of those equations. That's what systems of inequalities allows you to do. You know what?
Sure, why not?
Why not? It's
Yeah,
fun.
why not live fly?
Wait, let me see
Let's start with this. I have x minus 2y is 3. You know what? I'll make it easier on it. Let's just make this an 8.
Wait.
X minus 2y is 8.
Why would you shade the side that works?
Okay?
I don't know.
Wait.
That way your intercept's a little bit cleaner. What's up?
Can you repeat the question?
Okay,
Because I'm
so
missing
if it is
portion.
on the origin and then you pick a spot that's not on the
Oh.
line and it doesn't work, You shake that side.
You shade.
Shade.
You
Side
shade
the side that
Side
doesn't
that
work.
works?
Correct.
Why did you
See,
say
yeah.
the side that works? That's my
because you want to cover the truth. Always cover the truth.
Oh.
That's all it is. You just want to cover up the truth.
Please double check it.
I'll look up truth. I'll put a little star. I'll write this down.
Okay, so x minus 2y is less than or equal to 8. What is your x-intercept?
8.
8. X-intercept at 8. Y-intercept at?
-4.
Very good. Keeping you up?
Yeah.
Solid or dotted between the two?
Solid.
You should put your side on the best.
Did that line go through the origin?
No.
So is 0 minus 0 smaller than 8?
Yeah.
Yes.
Okay, shade up. And then the next one, it's given to you in slope-intercept form, which hopefully you guys remember how to graph from.
Oh. I
Oh.
didn't realize that.
No,
Oh, I
forgot.
Why would we remember that?
I don't know. It's tough to ask these things of you guys. Y-intercept -4, slope of 3, so I should start at -4. I think it's just dumb luck that it wound up the same spot. Up 3, over 1. Up 3, over 1. Now between those, what do I make? Dotted lines. That one has to be dotted because it's just a greater than symbol, okay? Okay. Did that line go through the origin?
No.
Yeah.
Nope. So is 0 bigger than -4?
Yes.
Yes. Everybody see that?
Uh-huh.
And a lot of times you don't have to do the direct substitution because you can probably think in your head, 0 is bigger than 0 minus 4, so yes, that's true. What's up?
Wait, how'd you do that? Like,
Yeah.
like, okay, I get. Oh, you just solved it for like the. You put it in for the x and the y.
Yeah.
Oh.
That's all I'm doing. I'm using that 0, 0 as my test point. So it didn't go through the line, so I know I can use it. So all I'm doing now is just shading. This side also gets shaded upward.
Wait. That's a, oh, it did.
You can get some pretty funky displays when you go through these things, depending upon how the boundaries are drawn out.
I actually take care from patterns out to like just like this.
Yeah.
I just do, it's not thick enough. Yeah, I just take this like that, so it'd be better.
Kind of a little bit of a twist to this. I want to try and do this without a graph. So don't use a piece of graph paper this time.
Challenge accepted.
Okay?
I don't like it.
I want to not use a piece of graph paper for this problem. Just to give you an idea of what we're going to do when we get into section 3.4 next week. Now, if I'm looking at this, it says x is greater than or equal to 0, y is greater than or equal to 0, and then I have the standard form equation, 4x plus 3y is less than or equal to 24. Now, what I want you to think about, what side of an xy grid gives you values that are x is greater than 0? Everything to the right. Okay? Now, what part of the grid gives you everything that is y is greater than 0? Everything up. What would be the overlap of those two parts? The first quadrant, right? Quadrant 1, everybody okay with that?
Yeah.
So this is a quadrant 1
It's like
style
like
problem.
Like this is 1, 2, 3.
And I know that it's got to be going this direction and this direction. Everybody see that okay?
Yeah.
That's telling me that it's a quadrant 1 problem because all the values of x are greater than 0 as well as all the values of y are greater than 0. I have some certain parameters that I need to graph from. Now I do my quick graph. What's my x-intercept? 6. Notice, I didn't walk anything off, I didn't do anything, but I put an ordered pair there. Does that mean it's 6?
Yeah.
Yes! What's my y-intercept? 8. Okay, what do you think I'm going to do?
Put a random dot.
Dot and label it.
Dot.
When I connect those two, will it be solid or dotted?
Solid.
Did that line go through the origin?
No.
No. So, in the world of our possible boundaries, for these first two to hold true, this also has to fall in this quadrant. We okay with that?
Yeah.
So is 0 plus 0 smaller than 24?
Yes.
So it's true coming towards the origin, which means my shaded region is basically just in this little triangle.
Shade it.
The arrow's confused.
Yeah, just shade it.
Yeah, just-
Well.
We'll put snowflakes in it
How nice.
because it's hot out. Yes, it does.
Yeah.
Because you know they have mountains, right?
It's very Hawaiian, like that's all nice and.
True, but it snows on them. Go back to Siberia. I know, she's Russian. But not in a hurry.
Yeah, they're like.
That's awesome. Huh?
What's she saying?
I said she's Russian.
It's like, bye.
Is the Siberia joke?
I'm not too big.
And then I said, but not in a hurry.
At my time.
And there wasn't any drama.
Homework to do. Like, if I roll up these and just like.
No, yeah,
Okay.
we go together, yeah.
Look of disappointment.
I didn't do anything for that. I put them up.
You probably won't, we will do stuff like this a lot more in 3-4, but I thought it was a good idea to show you how we can create boundaries. Okay? So take a minute, and I want you guys to do this one on graph paper. Okay?
There it goes. Mine. There goes.
X is greater than or equal to 0, which means it's a first and fourth quadrant.
Wait, that's
For real.
Yeah,
Oh, that's
because X is all on this side. Remember, X is greater than 0.
Got it.
So then what happens?
Just flip your graph sideways. All right, so now you start at your intercepts, and we'll start shading. So our first one is at -1. Walk a slope, up 2 over 1, up 2 over 1. Between those, do I need to worry about graphing that going behind it?
No.
I don't, because I know my boundary is always going to be going towards the right. Just make them dotted going up.
Yeah, I forgot that.
Okay. That did not go through the origin. So is 0 greater than -1?
Yep.
Yes.
Yes. So I'm going to shade this way. Okay.
Which one is it?
The reason that is because it comes up towards the origin. It's below the origin, so it's going to go up.
Oh.
Okay, does that make sense?
Yeah.
All right. Do the next one. I have 2x plus 3. If you've got different colors or pen and a pencil, sometimes it's helpful. Not a big deal, but 1, 2, 3. Same idea. It's got a slope of 2. I don't need to worry about going up below that. So, is 0 greater than 3?
No.
No. So this means on this side it would be false. So I have to shade above it again. So the overlap for all these then would be above this line. Okay? Like I say, sometimes it's cleaner than others. This one, just because the lines themselves are parallel, it's a little bit tricky to see how it blends in.
So then would you like erase like the blue?
No,
one?
you don't have to. Because I know where the overlaps are. I know what it's supposed to look like. Okay?
It's right here. That's.
It depends on what the problem is. You always shade towards truth. If it was false, you would if just example. If this is false on that side, which means this side would have to be true, so I shade towards the truth. If it happens to be where it's true on this side and false on that side, I shade towards the
They're both
truth.
shaded.
No matter what, I always shade towards truth. Okay, so if it's false, Yeah.
Need like different.
I just didn't-
It's just one of those things. You always want to cover up the truth. It just depends on where it goes through. That's all. Okay. I think that's about all we need to do, right?
Yeah.
Yeah.
Sure. So let's see. This is section 3.3. I don't want to do too many of them on Friday. I don't really do a lot of stuff on Friday anyway, because and it's a 3-day weekend, which means you won't do it till Monday night.
I won't do it till Tuesday morning.
I never even. I'm so confused. I was so lucky that I covered it like real fast.
I must figure out how to make it last.
All right, so this is on page 160. I'd like you to do numbers 36.
What's the homework?
Yeah.
I'm just gonna take my.
I'm going to give you 6 of them. It's just one front sheet of your graph paper. Okay? I'll give you 36 and then 46 through 50. 36 has 2 graphs you're putting on there. 46 through 50 will have 3 and then maybe 4 of them on one. So they get to look kind of funky after a while. All right?
Sure.
So it's all one page?
Well, yeah, you don't fit on just one sheet of that graph paper.
I think this is just one page, it's all down there.
I'm a